One of the ways that our white blood cells fight COVID-19, among other diseases, is through an oxidant called hypochlorous acid. The formula is HOCl. The stuff in commercial bleach is very similar, actually. It's sodium hypochlorite, NaOCl. It's a lot less effective and a lot more toxic because the hypochlorite in sodium hypochlorite is negatively charged. And given that the viruses are coated with negatively charged particles, it very slowly diffuses into the virus. The other problem is that the hypochlorite ion reacts to form all sorts of toxic byproducts like chloramine and chloroform. Hypochlorous acid is neutrally charged and does not react with things like ammonia, which is in our obviously our bodies are full of it, right? So it's a lot less toxic. The reason you can't go to the hardware store or the grocery store and buy hypochlorous acid is because it is very unstable. It decomposes within half an hour of making it, so you need to make it at home. So here's what I'm going to do. I have here a USB battery, 5 volts, and I have this adapter that takes a USB port and puts it into an alligator clip. I'll show you why I need 2 sets of clips in a second. Here I have 2 graphite electrodes. This will not work with metal because the anode will corrode. Basically, any metal besides some of the very unreactive ones like platinum or iridium will dissolve instead of producing hypochlorous acid. So I'm going to make a solution of, I would say, roughly 1 tablespoon of salt to about a cup of vinegar. So here I have Morton salt. Make sure it does not have iodine, because iodide will oxidize a lot easier than chlorine, and depending on what you're doing, it could stain whatever you're it's a purplish black solid, so probably not a big deal because it's only 0.01%, but still it's a lot easier just to get non-iodized salt. Okay, so about 1 tablespoon or so. I'm just eyeballing it. It's not a big deal. And here I have some white vinegar. It is, how many percent is it? It is about 5% acidity. Now, I've seen some people dilute the vinegar. I don't think that's necessary because some of the vinegar is going to break down as this goes, as the salt becomes, well, it electrolyzes to sodium hydroxide, which will neutralize the vinegar, which we want because we don't want additional vinegar to react with the hypochlorous acid to make chlorine or other higher oxidants of chlorine. So just enough to dissolve the salt. If you dilute it, it will just make it less conductive and it will take longer to make. You can always dilute it after you're done with the process. I'm going to stir this, and let's see if we can zoom in and see the bubbling. Okay, that on the top you have the cathode, the negative electrode, so positive hydrogen ions, because vinegar is acidic, right, are migrating toward the negative electrode and becoming hydrogen gas. I wish I had my lighter on me so I could show you that it was hydrogen. And notice how there's very little bubbling on the positive terminal, because on the positive terminal, the chlorides are migrating there and becoming hypochlorous acid. The problem with this process is that the vinegar itself will consume some of the chlorine being produced because it's an organic molecule just like your viruses. One way you can get around that is instead of using salt and vinegar, you can use hydrochloric acid, usually about 5 to 10 milliliters per cup of water. The problem with this stuff is that if you get the concentration too high, it will actually make chlorine gas, which is toxic, and then it's escaping from your system and you're not making a hypochlorous acid, right? The other problem with this stuff is that it's not really edible. It has a lot of contaminants in it. It's yellowish in color. But if your goal is to clean something, it's probably okay. I wouldn't recommend using hypochlorous acid you made from this on your skin or ingesting it. Thanks for watching.